Hello and welcome to Innovation Webinar, the Critical Facilities Perspective. My name is Bhavesh Patel and I'm Vice President of Global Marketing at ASCO Power Technologies, a Schneider business. I'm very excited to host another session of our Innovation Webinar series, which have been consistently averaging hundreds of live attendees. And I truly appreciate all of you joining us today and hope you learned something new today. I've had opportunities to present at various conferences, published articles, etc., so I can add to the body of industry knowledge. And today is another such event that continues to build that body of education for any critical facilities electrical infrastructure. This particular event was recorded earlier, but we will have live Q&A. So please start thinking about your questions and populating them in the questions block of this webinar tool. This event will earn a professional development hour for every attendee, and for some, you may qualify to earn a continuing education or a CEU unit once you successfully pass the quiz. Again, today I'm really honored to discuss these topics related to critical facilities electrical infrastructure with Mark Hamilton. He's Vice President of Global Data Center Engineering and Construction at Cyxtera, as well as Joseph Reel, who is Vice President of Solutions Architects at Schneider Electric's Secure Power business. Mark and Joe, welcome to Innovation Webinar. Can you please give our audience some background about you and your work, starting with Mark?
Yeah, hello. This is Mark Hamilton, Vice President of Engineering and Construction for Cyxtera Technologies. And I started my career in airborne radar, transitioned to power systems with a local cat dealer where I did projects up to and including 10 megawatts of generator power, paralleling switchgear, industrial projects, and marine projects. From there, I moved on to facility management with America Online in Northern Virginia, and then on to Terramark, where I was facility manager and then moved into construction and engineering. From there, I've moved on to director of engineering for Cyxtera and recently was promoted to vice president of engineering and construction.
Thank you. Welcome, Mark. Joe, if you can introduce yourself.
Sure. Good afternoon, everybody, and welcome. I hope you all are doing wonderful and safe. My name is Joe Reale. I have the honor and privilege to serve as our Vice President of Solution Architects for NAM Secure Power. My background started in the United States military with the United States Air Force nuclear program. I have an electrical engineering degree, mechanical engineering degree. And I've been in mission critical facilities my entire career. Previous to Schneider Electric, I was serving as Senior Vice President Engineering Executive over global data centers for Bank of America. Design, build, operate, change management, problem management, compliance management, and of course, risk management. And so here at Schneider Electric, been here for 8 years and really Bhavesh and Mark really super excited to get in and dig into this exciting topic and can't wait. So thank you for having me.
Thank you both for joining us today. So for the audience, today's conversations will focus on 4 key broad topics, and they're all related to the critical facilities electrical infrastructure. The first will speak about COVID and its impact on the critical facilities. Then we'll touch on the critical facility design strategies. Then we'll move on to sustainable technologies in critical facilities. And then we'll finish off with digitization in critical facilities. So let's just get into it with our first topic of COVID and its impact on critical facilities. So Mark, I'll start with you. This COVID and the associated lockdowns has pushed bulk of the society to either adopt or grow use of digital technologies. And in some cases, the shutdowns have created a havoc on the critical facilities. They have shut down the critical facilities in some cases, or they have pushed them into doing something different than what they were designed for. How did these critical facilities cope with all these changes impacted because of lockdown?
critical facilities in a data center, it's an industry that we've always looked at what is out there, what we can do, and then how do we react to those situations. So COVID has pushed us not only from a process and procedure, but how we document. So we have to document not only what has occurred, personnel, access control, down to being able to figure out where people have been, when they've come in contact, and how then we communicate that out to others so that we don't spread this COVID issue throughout the industry. So I'm not sure exactly what you were looking for an answer from the question. Joe?
Sure. Anything, the lockdown changed the way facility was used. And critical facilities saw an increase in its use in some cases, or maybe a complete shutdown of the critical facilities. Hospitals, hospitals are critical facilities, but they had to impose a lot of restrictions in that hospital environment. On the other side, a data center might have seen an increase in the use of data center, even though people were not working in the data center. So Joe, from your vantage point, how do you see them facing or coping with this change?
It's a great question. So yeah, thank you. I think, at the end of the day, there's, I would say, and Bhavesh, you touched on it at the beginning, it's forced us to do things differently. Working remote, homeschooling, higher education, all of that means a heavy reliance on the network. And the network is kept alive in data centers like Cyxtera. So there has been a dramatic increase in the demand of network. And of course, the reliance and the uptime of that network absolutely done every day in data centers. But guess what? That is now forced even outside. For example, our network, it goes out, this webinar doesn't work, making the network incredibly critical for continuous business operation day in, day out. Now, the data centers at Mark and Cyxtera are core to keeping that network alive with redundancy, with backup and so on. And Bhavesh, Mark's going to get into this later, talking about designs and sustainability aspects of it. But make no mistake about it, the data center that Mark operates and his portfolio globally is a key component to making all of this COVID life a reality of remote work, high demand of network. Mark's got to keep that network up. If it doesn't stay up, we not only have business impact like we used to have, but now that impact far reaches out to schools, to us, work from home, and so on. So that's what's happened in data centers. And thank goodness, data centers, as Mark has explained, they've been doing uptime and reliability for a long time. And so they were prepared for this. Now it's caused a little bit of change, and Mark and Bhavesh will get into that in a minute.
So Joe, you touched on a bunch of things, but you touched the need for uptime of a lot of these facilities. And so along those lines, these digital technologies, we live in a digital world, right? More and more, everything we do has elements of digital technologies coming into play. And those digital technologies need continuous supply of electricity or power. Now, for some of these critical facilities, like a hospital, there has been regulation in place such that the hospitals were mandated to ensure they have power continuity. So if they lose their primary source of electricity, they have an alternate source available. But at least from a mandate standpoint, this mandate was not applicable to other elements of the digital infrastructure that we are dependent on, and to newer elements of digital infrastructure that might be coming into this mix. So the newer elements of digital infrastructure are, say the Google data centers or the cloud data centers. The cloud data centers that are just addressing a business need at least from a mandate standpoint, there was nothing that required them to put up power continuity. Business needs, yes, but mandate, there was nothing. Other segments like a photographer that has, because everybody's taking digital pictures, the backup for the photographer might be in some kind of a network that, if that photographer goes down, yeah, you have inconvenience issue, but there was no compliance issue. So the power continuity equation itself is changing. But how do you see this evolution evolving with respect to power continuity or backup power for all critical facilities? Do you see that kind of mandated requirement extending across all critical facilities or still limited to the niche applications?
I would think you're still at the niche application, because at the data center level, whether that's hyperscale, whether that's enterprise, whether that's co-location, we have SLAs with our customers where we are forced to mandate that power path, whether that's UPSs, generators, some sort of on-site generation. Those things are mandated by our business. Today, they are not mandated regulatorily, but they are mandated by our business.
Okay. Joe, how do you see this evolution playing out?
It's a great question. I actually do see some regulatory requirements coming. I'll give you a simple example. Everybody talks about a generator. It's not mandated, it isn't mandated. Well, where there are generators, it's mandated, isn't it? With the amount of fuel and runtime based on the NOx gas, right? Tier 1, Tier 2, Tier 3, Tier 4 generators become 20 hours, 30 hours, 40, 50, 60 hours of runtime, all based on the amount of noxious gas and fumes it's putting out. And so the answer to the story here is we're going to continue to see more regulation in the industry, and I think we're going to see more incentives in and around sustainability. I think we're going to touch on this in a moment, but I think the power requirements and the availability of uptime, I think in a roundabout way is already regulated. You just can't put any generator at any site. You have air quality boards. You have a lot of different things. So I think the regulations are going to continue. I think they're going to actually migrate a little bit more, and we see this in the West. And so the regulation does require some amount of sustainability impact, economization, et cetera. I think we're going to see that continue.
Okay. So you're right. We do see the regulatory issues, but they are not specific to the power path. They are associated with the generators' emissions. They're based off of water usage. Those types of things, yes, are being regulated, but the actual generator backup and how we go to market is not today.
Right. Great.
Okay. Great. So let's move on to our next topic of critical facilities, electrical infrastructure design strategies. So Mark, what changes or what newness have you seen in the electrical infrastructure design strategies for critical facilities?
On critical facilities, we're all about uptime. So you're looking at your designs, whether that be a 2N, an N+1, or even an N+1+1 or 2N+1. So it depends on what your go-to-market strategy is. In a co-location market, are we looking to go as much power as we can get out of a given set of infrastructure? Is that a greenfield build, or is this something that is a retrofit of an existing facility? All of those things need to be taken into consideration as we take a look at how that facility is going to be designed going forward, and whether we're looking at things like efficiency on the UPS. Are we looking at utilizing economization, water usage, PUE? So all of those things have to be taken into account as we go through the design process.
Great, great. So you touched on the design strategies maybe for the larger facilities or some of the ultra-critical facilities. But Joe, let me ask you a little different question.
Yes, sir.
Along the same line. This whole energy landscape is shifting towards electricity. As you may be aware, California has declared that after 2035, I believe, or somewhere in that ballpark, all the future homes built or constructed will only have electricity as the incoming energy source, right? And this could be playing out in other industries too, besides the housing market. Office buildings might only have electricity as the incoming energy source. Gas stations might change. So the dependence on electrical infrastructure, as we have discussed early on, is becoming even more critical. How does critical facility in that mindset then improve the resiliency? Because there's more people depending on that same energy pipe.
Yes. I think a couple of things. Number one, I think what's available today from a renewable and sustainable energy resources weren't really available 10 years ago. So as you talk about the critical power and availability, there are other sources of power now becoming available. Battery energy storage, solar, wind even. Okay, these are all now viable options in addition to the traditional utility supply. Mark and his company and others like them are taking a look at having the availability of multiple different sources of electricity. And Bhavesh, to your point, if any one of those sources goes out, in yesteryear, that may have caused significant impact. Going forward with a distributed energy pool of resources, that impact may not be as great. So that's kind of what we're seeing.
So essentially you're saying we're going to spread the risk by having other sources generate electricity and kind of feed that pipe.
Yes, and I'll say something else to touch on what Mark was talking about, and I think it's really important, what Mark said. When we talk about the data center and co-location and just the data center in general, we, seeing designs of 2 parens n+1 and that would be more like tier 4. We've seen the redundancy of the designs go down just a little bit as the redundancy in the IT kit has increased. Okay? So as a financial institution, as an example, always used to build perhaps at 2 parens n+1. Now today are building at n+1 or 2n. But it's not because and I want to make this point clear to everybody, it's not because uptime doesn't matter. It's the way that we're achieving uptime. And Bhavesh, to your point, just a second ago, about having different things, doing things to together compensate for reliability and resiliency. The same thing applies on the IT kit, which is then but allowed Mark to really open the mind up on how to more design a system that has the redundancy, the reliability, and the resiliency, and make it a very good operational design so that it can be operated without error. And those are 3 important aspects of that.
Great. Thanks, Joe. So then, Mark, let me ask a little different question again along the same topic that we've been discussing. It seems like the label of critical facility or critical category in general is going to become a little more mainstream than it is today. Definitely more so than it was yesterday, right? Because as we become more dependent on electricity, and as even though there's more generation capacity coming into the stream because of all the different technologies that Joe referred to, that everything is going to become critical because of the nature of the digital work that it's doing. But from a construction standpoint, the need for speed and execution becomes even more important. And as it has happened with other industries, the need for speed may bring in standardization. So do you see this critical facilities adopting a standard electrical infrastructure across multiple segments? Or is it still going to play out by different segments playing unique to their segment needs?
That's a great question. And, the way I see it is we're going to look to standardize on designs. The design for one region environmentally may not work in all regions. So we're going to have what we'll call snowflakes. And those snowflakes are individuals or one-offs, but we're going to try to standardize on product, on scalability, on size of a facility, and on technology. So we're going to have the standardization, but you are going to have the one-offs based off of environmental conditions. Phoenix is going to be very different than what you would do in Toronto.
Absolutely, absolutely. Joe, is there anything else you would add to that?
I'll add one thing. I think it's important. I've said this a long time for many years, but there's no one single answer here. But there is, however, the right plan. And here's what I mean by this, and I'm going to support what Mark said. There will be design standards, but there's going to be a design standard for Cyxtera. And the design standard for Cyxtera may not be the design standard for Bank of America or for Goldman Sachs or for the next co-location competitor. So here is and everybody's doing this. They're finding the right answer. And the right answer is the risk profile that the company is comfortable with. And once the risk profile has been agreed to, now then designs can be designed and standards can now then be applied. There will not be, in my opinion, a standard design across all co-location data centers. There will be a standard design for every one of the major co-location providers as they look to optimize costs. To your point, very much increase speed, but here's the bottom line. We can't increase speed and we can't decrease cost if we're going to increase the risk. So all of three of those things, which is why there's a design standard that matches the risk, that matches the speed, that matches the cost. One standard per company that doesn't help the industry, but that's how it really will play out.
Totally agree.
Yeah, great point, great point.
And it'll be different per industry as well. When you start talking hyperscale, it's going to be different than co-location, to enterprise, to cloud. Those are going to be different standards and different form, fit, and function to go to market.
Yes.
Great point, great point. Again, I want to remind our audience that if they have questions that they would like to ask of either Mark or Joe, please start populating them in the questions block of the webinar tool. Let's move on to our third topic. And Joe, you already mentioned the sustainable concepts in your previous answer. So this third topic will deal with critical facilities and the sustainable electrical infrastructure. And my first question is something that, Joe, you touched on, but let me ask this anyway, and we can elaborate from that point forward.
Yes, sir.
Is that critical facilities by nature, they need to focus on uptime and or power continuity, right?
Correct, yes.
And so historically, that conversation did not focus on efficiency as much. The focus was more on uptime and business continuity or electrical continuity. In that mix of not having the focus on efficiency, how do you see sustainable technologies play a role in critical facilities?
It is a growing role. It is a very, very growing role, actually, because I think, so here's a little bit of provocativeness here. We've grown up as an industry. We really have. it used to be like the end justifies the means. And that's a very crude way of saying what you said, like, we're going to do something really neat. We don't care about efficiency. I can say very proudly that the data center industry does care about that now. And efficiency, starting way back when with the PUE reading that everybody's familiar with, right? That started to focus on this. We laugh, but that really did. And we can argue whether that's great or bad number, whatever, but it forced us to really pay attention and to say we have to do better. So when we were, and I'll tell you from experience, we were 1.6 this, 1.7 as a norm. That's not the norm anymore. It's way down lower. Okay? So yes, I see efficiency being a key driver. Once again, match to risk. I'm not going to take on the most efficient thing if my risk is through the roof. I might do that if I'm a different business that can accept more risk. Okay? So again, all of this, the risk profile plays a significant role in this equation, but everybody's now saying that actually, and I'm very proud about this statement, we actually care at the end is justifying how we're doing it today, whereas before maybe we had a blind eye to that. We care about the impact and the footprint we're leaving behind.
Yeah. Well, and Joe and I have had these conversations over and over and over again. And when you start talking about end-of-life equipment, you're taking equipment that was built 15 years ago. That's 0.8 power factor. Today, our UPSs are unity power factor. We're looking at facilities and saying, how can we take this facility from where it is? These are existing facilities, and increase that PUE to get us to a more efficient facility that we can drive costs down, not only for our business, but for our customers. And, you know, it's good stewards for the environment. We're looking at not only the electrical side, but the mechanical side. We can't ignore the mechanical side, because when you talk about sustainability, you're talking about the entire facility. And if your mechanical systems are inefficient, you're not going to be efficient as a facility, no matter what we do with our electrical.
Yeah. So Mark, you know, Joe touched on this. He mentioned PUE, and to me, PUE still is a measure of efficient utilization of the physical assets, right? But like auto industry has miles per gallon as the efficiency measure. That is kind of saying, not only do you efficiently utilize the automobile, but do you also efficiently get enough energy out of the gasoline that you put in so that you can go farther distance. Appliances have energy guide labels that have the measures kind of telling you the annual operating cost, which is not only capturing the design of the appliance, but how much energy is it going to use to operate it and give you the output. Do you see anything similar coming out for critical facilities?
I mean, that's a great question. You know, you have Energy Star certifications on facilities. We still have PUE. We're still looking at increasing our efficiencies by utilizing things like economization, those types of things. But an overall, kind of like they're doing in the industry, in the auto industry, we don't typically have that today. We're looking at the facilities as pieces and parts, and sometimes not holistically.
Yeah. Joe, do you see anything?
No, but you're making my mind start to innovate, because as soon as we develop one, we could really come to market. We really need something like that. I think it's really complicated. I think if we look way back what Dean Nelson started to do at eBay, where he was actually mapping the transaction from an eBay user buying something on eBay to how much compute did it use, to how much energy did that compute use, to how much cooling was required for that. and came out with some kind of metric. That works for eBay, perhaps, but it's very difficult to equate that power assumption to a MIP or a BIP. And I think I'm not sure how to solve that, but I see what you're asking. And now I need to be very innovative and be thinking about that.
Yeah, our Q&A was not supposed to be stump the expert, but it hopefully gets the audience thinking.
Yeah. So yeah, it gets everyone thinking about a solution to a problem maybe we haven't thought about.
That's right. Correct. So again, let's stick a little more with the sustainable concept, but touch on things that Joe, again, you alluded to, microgrid or combined heat and power. These are the concepts that have been around for a while.
Yeah.
Combined heat and power, definitely. Microgrid, as it's described today, may not have been around for a long time, but elements of microgrid concept has been around for a while.
Yeah.
And they have all contributed towards improving the energy efficiency. Do you see them becoming mainstream in the critical facilities?
Yes. I actually see them becoming more mainstream in a lot of industries, healthcare, I think college universities, campuses, I think large or medium-sized commercial development properties. I think microgrids are going to become very prevalent. And I think the ability to tie in energy sources that really weren't available at scale even 5-7 years ago that are today, as well as the technology of microgrid controllers and so on. I think they are here to stay and will become more prevalent as we move forward. Electricity is in high demand. Digitization is driving a lot of this. We're not going back to fax machines and beepers, I'm pretty sure.
Yeah. So Mark, from your standpoint, because you construct a lot of these facilities, how do you see this concept of microgrid, combined heat and power, all these other things that have been around for a while, how do you see that playing a role in critical facilities? And what do you think is the motivator for them becoming mainstream, as Joe said?
Well, some of it is the volatility in some of the utility costs. Take California, for example, this year with the wildfires. We saw volatility in that market, nothing we could forecast for. But if you had microgrid, you had, something, a Bloom Energy or something along those lines on that facility, you can then level that playing field.
That's great.
So those are where it's coming to be more prevalent, and folks are really starting to look at them holistically, not just as a one-off or trying to get some green credits out of that.
Great point. Again, I want to remind our audience to start thinking about questions that they want to ask of Joe and Mark, and try and even stump them, and start putting them in the questions box of this webinar tool. So both, let us move to the fourth topic, which is digitization in critical facilities and Internet of Things. So both of you, you know that the facilities have had building management systems for decades now, and they were historically designed to either simplify and or centralize the operation. Even with this growing digitization, where the electrical equipment had some kind of a compute or monitoring capability that was similar to the BMS, but it needs something beyond what a BMS has. And for a while, this data center infrastructure management, DCIM, was kind of the replacement of BMS in a critical facility. From your viewpoint, do you see something evolving beyond BMS that is similar to diesel or something completely different? How is the electrical infrastructure managed in a critical facility?
So BMS is always going to be around, a building monitoring system of some sort. Back when we were in the early 2000s, that was standard PLC control. Then we moved to distributed I/O. Now we're moving to something different. Are we going to move to an AI where we start to have this facility thinking for itself? We know we're going to have a load coming in a certain part of the facility. Well, the mechanical systems react to that electrical without, or be proactive instead of reactive to that load. It helps us on our efficiency. It helps us on our reliability. And then our systems are not taxed to try to recover from a very large load step or a new deployment. Is that something coming? Probably. Do we have that today? Not in total.
Okay.
The other piece is we've got to start getting to where we have a common platform. Today we have Snyder platforms. We have multiple vendor platforms. Some of them communicate well, some of them don't. So those are things we've got to overcome to get to a point where we can have a fully centralized system.
So, and along the challenges that you outlined, Mark, another challenge that I see is dealing with data. So, this digitization in BMS and the advent of everything being either monitored or some kind of compute capability in even the basic electrical infrastructure means we are kind of adopting Internet of Things in everything we do, everything we build. And Internet of Things brings a whole lot of data, high volumes of data. And the data is only helping you if you analyze it appropriately and take action, right?
Correct.
5G is starting to roll out, and in my mind, 5G is going to even magnify this phenomenon I just described. So there is this term big data out there. I think big data may even come to critical facilities. So if that happens, what kind of management expertise is required to manage this critical facilities in the future?
Well, first, just because you can doesn't mean you should when it comes to the amount of data that's available to you. Yes, it's good that we bring that much data in, but now we have to evaluate, is that data useful to manage that facility? So that's where it really comes down to, and where the rubber meets the road is. Are we collecting the right data to make intelligent decisions?
Yeah. Joey, anything to add to that?
A couple of things, yes, please, and thanks for that. I think we have to separate it a little bit, right? I think as take a building automation system in a data center, it's got 25 to 55,000 points. Temperature, pressure, VFDs, pumps, valves, all this. That is not going outside of that facility. That's what we're going to call localized edge. All of it's on its own private network, and that private network is using those process variables, temperature, etc., and controlling something in the facility. That's one thing. Now then, out of those 55,000 points, like Mark said, which are the 7 that are really critical? That if I take 7 from the BMS system, what are 7 from the power system? And let's not forget that the mechanical and the power system are there to serve one thing in a data center. That is to provide power to the compute load. So the thing that needs to be cooled is the computer. So the third rail or leg of the stool here that Mark's talking about is that today's system, we have a building automation system. It does one thing on one network. With a SCADA system, electrical infrastructure does one thing on another system. And oh, by the way, That's called OT, or operational technology. Something called IT, the OT is there to make the IT work. So the holy grail is to then take the IT data. And we're not talking about MIPS and bits. We're talking about core temperature. We're talking about fan speed. We're talking about the infrastructure in the IT. The infrastructure data in the IT mapped down back to Mark's building automation system, which now turns on the chiller plant to cool it because the IT equipment's drawing more electricity. That's where we're going, okay? And the only way to get there, and it's going to be a very difficult challenge for the whole industry to solve. Mark said it at a high level, it probably just went to everybody. But he said we need a platform. The autonomous vehicle is a great example. 5 years ago, my vehicle was all digitized with a screen over here and this, that, and the other thing. But guess what it wasn't? It wasn't on a single platform that would allow that vehicle to drive autonomously. The automotive industry put the whole entire control system, command and control, on one platform. Engine is the same engine, but digitized with 50,000 temperature and other sensors. Transmission, same thing. Talking on one platform. And when you're able to talk on one platform, you're able to make a decision, gather data, and make a decision quickly. Okay? Now, we have an IT network and 3 different OT networks. They need to be the same platform that Mark described. And once they are the same platform, I'm now going to know that at 6 o'clock every day, I run a batch on finance, looking at every trade that Wall Street did at 6 o'clock at night when Wall Street closes. I know that, so I'm going to then prepare the mechanical plant and the electrical distributed energy resources to now then ramp up the battery so that I can run the chiller plant to cool this batch all efficiently. That's the data center of the future, Babesh. That's the platform Mark was talking about. That's the digitization of critical facilities, but not only critical facilities, but really everything inside hospitals and data centers are 2 great examples where that bridge between IT and OT become one platform where I can do things. And once again, I don't need to know the MIPS and the bits. But we need the infrastructure data of the IT equipment, fan speed, compute processing power, energy resources. Then we can take the next step. It's coming, but we're not here yet.
Yeah. On that note, thank you very much, Mark and Joe, for this very engaging conversation. Let us end our recorded discussion here and meet the audience on the live session so we can answer their questions.
Thank you.
Thank you.
Hello, Mark. Hello, Joe. Welcome to the live segment of Industry Perspectives, Critical Facilities.
Hello, Baresh.
Hello, Babesh. Thanks for having us.
Yeah, so it seems like we have an enthusiastic audience with us today, so let's dive into their questions. And the first question, Mark, comes to you. And there are a couple of different versions of this question, so let me ask hopefully both the versions in one go. So the question is revolving around use of diesel backup generators and your role, Mark, or your view of their role in the future, considering the environmental concerns over using them. So the question is kind of asking you to share how you see their sustainable and resiliency strategy kind of looking like in the future because of some of the stigma that comes with diesel. And the second part of that question is natural gas the alternative to diesel?
Okay, both great questions. So in my opinion, diesel generators will continue to be utilized, especially in existing facilities. Trying to retrofit diesels out of those facilities may be difficult and or impossible. That said, emission after treatment strategies will need to be evaluated and executed to continue to utilize those diesel generators. Emerging technologies may play a role in the future, in future builds, really as we take a look at sustainable initiatives and looking to resiliency of these sites. Is natural gas the answer? It is one possible answer. There are still some issues around natural gas and their ability to take block loads, those types of things, but many of those can be worked out through the design process. So is natural gas viable? Yes. Joe,
Okay.
anything to add?
No, I think you hit it on the head there, Mark. I would say one other thing, maybe just to add something. So yeah, I'll add a little bit here. I think so. I had an opportunity to speak with some executives in the generator. They make generators, and asked a question about just what was just asked now. What's the future? And there is a tremendous amount of work being developed on a cleaner, the ability for the generator to output much cleaner. And I think that there will continue to be that work and that effort with regards to diesel generators. The other thing that I will say is that a couple of things are important. Number one, the amount of electrical outage in this country is going up, the amount of frequency, and the duration of the electrical outage is also going up. It's public knowledge. It's not anything provocative. Everybody can go find that out themselves. That being said, a lot of the energy sources that we're talking about are not a continuous run. And in data centers and mission critical facilities, we have to have the ability to run continuously, right? So if I have 72 hours worth of fuel storage, so long as I can continue to get fuel, I can continue to keep the data center alive. So I think that continuation or the requirement to be able to run your data center or your mission critical facility in an extended utility outage time, there's not a whole lot of options out there right now besides fossil fuel.
Yeah, thanks, Joe. Thanks, Joe. So, following up, there's another question from the audience. And this question might be a little bit provocative, but let's at least have a go at it. So the question is that we are aware of standards which require the engine to come online within 10 seconds for a life safety in a hospital or a mandated environment. Do you see, in the similar vein, a mandate, say, for hospitals where the patient records have to be backed up every 12 hours? So there is a similar pressure on the IT infrastructure, just like there is a pressure on the electrical infrastructure. Joe, I don't know, maybe this is something you want to take on?
I'll give an overview of that. It's a great question. And I would say that the answer is yes. There is going to be and will continue to be regulations with regards to, call it IT, but just say data. And, with it's a financial regulatory, there's healthcare regulatory, and as everything becomes more digital and we're starting to do more things with more data, more personal data being shared on devices, online banking, et cetera, so on, regulations will continue to increase. I mean, look, all you got to do is bring up the headlines. What are we talking about with big tech? Having regulation on big tech, having some sort of standardization. It's almost like the Wild West in a sense. And so there will continue to be more regulation, and it's developing. Okay, we will continue to see more and more of it. I can't tell you exactly what all of that is because it's an emerging thing. And unfortunately, as we have an emerging thing, there are always bad guys that are always trying to do things, hacking this, doing this, security protocols, cybersecurity standards. All of this is going to be wrapped up into a I would say a little bit more substantial standard with regards to IT infrastructure and data. We hear about data sovereignty now. Data being generated in one country has to stay in one country, as an example, just super high level everybody, that stuff's going to continue. We're not going backwards. It's not going to be unregulated, and it's not going to be a free-for-all. And as the data becomes more important and more personalized to us, more regulation will continue to be piled on top of it.
Yeah, so I warned you that this is a little out of the norm question, and there are a bunch of unknowns, as you point out, Joe.
Yes,
Let's
sir.
go on to the next question. So, Mark, this question is directed at you. In one of your previous responses, you mentioned Bloom Energy. And so the question is, do you see fuel cell use in critical facilities increasing? And if so, can you share some examples? And more importantly, how are they used? Are fuel cells used in lieu of generators, or is it a completely different type of use?
Okay, well, we'll take first it is a great question. And the answer is yes. Microgrids, CHP, fuel cells, and any of these other energy storage technologies are being evaluated, they're being deployed, and it's really where they make sense. In some cases, a site doesn't have adequate real estate for the deployment. Some of these are lease properties with landlord approval requirements, and others are the interconnection requirements and their limits, which can limit the capacity that you can put on with fuel cells, microgrids, CHPs. And those limits, they can impact the financial and operational benefits of those technologies. So each of those applications and each site must be evaluated individually. So I think that answers the first question. The second part is, where are they being deployed? It could be in any facility across the nation. There are regulations that are making them more beneficial in certain areas. So those are the areas that we would be focused on.
Yeah. Do you see the fuel cells being used in addition to generators?
They are in addition to generators, since you still need to have, you'll have utility on utility, you'll have the fuel cell, and in the event that you have maintenance and or failures, the generators are still going to be required for your resiliency and reliability.
Okay. Great. Let's move on to the next question. And I know, Mark, early on you had said that you experienced some weather and ice storms in your neighborhood. And so the question is along those lines. Severe weather seems to be more frequent event, right? I mean, just watching the news yesterday, they were showing about 3 major systems impacting a good chunk of U.S. And in the winter months, those impacts are pretty severe, right? Ice storms and things like that, which you're experiencing in your neighborhood. So is the weather and the severity of the weather changed anything for critical facilities in terms of electrical reliability?
Yeah, that's a great question. And as we saw last year, wildfires and abnormally high temperatures in California had a dramatic impact. We saw utility rates become volatile and unpredictable. We had outages. We saw sags and swells. We saw rolling blackouts in some locales. And utilities actually invoked demand response type programs to reduce the stress on the grid. That's a big factor, is everything we have, not only in the data center industry, but even work from home, creating a situation where more air conditioners are being run. So we're seeing the grid get stressed. So I know those are just a few examples of the grid reliability issues. So yes, severe weather has had an impact on electrical reliability, and it has changed how we really look at utilities and budgeting for utilities. Our operational preparedness procedures and processes have changed. And that's not to mention that, we're going to look at additional utility programs that are out there. California is looking to allow diesel generators to be run in these situations of a utility grid stress. So hopefully that answers the question.
Yeah. No, it does. Joe, you touched on the infrastructure and security issues. And so let me ask a question of you along those lines. This question has come up about security in the context of standardization and digitization of the infrastructure, right? When you standardize, when you digitize, and everything is online, quote unquote, does the security not become even more severe because everything is exposed online?
Yes, a great question, but yes and no. Okay, so for example, you have a data center, you have a building automation system inside the data center. The building automation system is turning on chillers, cooling towers, variable frequency drives of pumps, temperature sensors, dampers, air handling units, the whole 9 yards. It's command and control. Absolutely command and control. But here's the thing, everybody. That is a private network inside the facility. Okay? Right? Okay? I'm not actually taking all of the 58,000 points from temperature sensors to pressure and chiller start, stops, and pump alarms and everything, and running that in an external cloud outside the building. The main controller is inside the building. The network is inside the building. It is secure inside the building with the firewall and so on, plus with authentication requirements to get into the system on site. You start to keep it sort of in-house, in the walls of your network security system. Okay. Now, there are points on that system that are going to be important for power efficiency, or if I'm going to do a metric, how is my building running? I have 80 data centers across the country. I could take data points, not command and control, just data points out of the system and export that. It's just a data point, 75 degrees. Nobody's going to do anything with that. You can't do anything with that to cause impact. But now I can take that data and compare that across my other 8 buildings, taking non-volatile or non-controllable data out and doing something with it, okay? So that's one thing. The other thing that you got to think about, I think, is cellular technology. Everything inside the building is mostly Wi-Fi. Wi-Fi is not that secure. So you look at your neighbor's house, you can see that their Wi-Fi is on. You can see it in your house. It's not great. Cellular networks offer a lot more security. And what we will see with 5G is OT technology, like a temperature sensor, has a small radio in it, more cellular than Wi-Fi. Okay? These are things that enable us to maintain security better, okay, than we currently have. Then there's other technologies that's coming out there, like Wi-Fi, light network. Light doesn't pass through walls. So I could have a completely private network with no ability for that light to exit my 4 walls and some bad guy get it, okay? So there's a lot of technology happening with network security, and network technology in and of itself, okay? But we don't run command and control in any mission-critical facility worldwide. We do not run that external to the facility. A hospital, a data center, nothing is run externally in the cloud. Everything is mostly localized edge or local control in a facility, and then either a window in for your chief engineer or something like that for alarm acknowledgement on the weekend, something like this here, but not command and control. Hope that helps.
Yeah, no, that's great. Mark, the next question is for you, and this is probably a little loaded question, but hopefully you have a short answer to this. You said something along the lines of the challenge is coming up with one standard, and you kind of said that the geographic or segment wise there could be standards that may evolve. And so the question is also on the other extreme, saying why do you think there is no possibility to even come up with a global standard?
And global standard reference what?
Anything. I think the question doesn't specify, but let's assume that it's a global standard for designs. That, I know you made the case why it's even not possible for a regional standard. So the case is probably worse to come up with a global standard, but from a design viewpoint, can you elaborate why it's challenging to come up with a global standard?
Well, a global standard for design, you can have a design intent. But when you start looking at specific technologies and how we would design to sustainability and reliability, there are products that work very well in a colder climate that would not be adequate in a very warm environment.
Yes.
From a cooling technology.
Yep.
So it is, in a lot of cases, our constraints are environmental conditions, and we have to design around those environmental conditions.
Right. And I'd like to add one thing to that, Mark, because I think you're right on. I mean, a couple of things. Question 2 or 3 prior to was, and then around, do you look at environmental conditions or electrical conditions when you're designing a data center? And the answer is yes. And I'll give you some examples. So I made a mistake and built a data center with outside air economization in California, but they harvest walnuts out there, believe it or not, okay? And all of this fuzz from the farmer's field blocked all of the dampers and the air intake to the facility. So while an outside air economizer looked great on a piece of paper, we didn't do enough diligence with the surrounding area to figure out the air particulates. Here's another example. I built a data center in Chicago. It's a financial data center. I really didn't have a generator. You know why? Just look at the history of Chicago in itself with electrical. It is one of the most robust token ring electrical infrastructures around. Hardly an outage in downtown Chicago. Now, if I were just to blindly apply a standard, I would have had to figure out how to put a generator on the roof of Sears Tower, which is impossible. Okay? So whenever you're doing something, you always have a design intent, tier 3, tier 4, something along those lines. But then you absolutely must, look at the environment and the geography at which you're designing and building in and make the right choices. The cooling plant that I choose in the Pacific Northwest is not going to be the cooling plant that I pick in Southeast Texas. Okay? Now, that is very important. There's no one, I say this often, there's no one right answer. There's always going to be a right plan. And the plan for Mark and Mark Hamilton's data center in Chicago is going to be different than the Joe data center in Southwest Texas. Okay? And so it's really a mix of risk plus the risks that are out there. Okay? So if you know that you have a high volatile electrical area that you want to build in, well, then you're going to have to take some design things to compensate for that. In another area, that may not be the case, but you might have some other problems that you need to design around. Okay? So that's kind of why it's difficult. I think a design intent is great. Voltages, frequencies are all different across the world, or differences. All of those play a role into, some of that type of thing.
Great, Joe. I know we're over the 1 hour time limit that we had set up, so I want to bring us to the close of this event, and we will respond to the balance of the questions separately, directly with whoever asked them. I want to thank Mark Hamilton, VP of Engineering and Construction at Cyxtera, and Joe Reel, VP Solutions Architect at Schneider Electric's Secure Power Business, for your time today and sharing your thoughts with our audience. I myself learned a lot of new things. I'm sure that the audience did as well. And I also want to thank our audience for their participation and engagement. You've flooded our events with questions, which makes this discussion even more interesting and educational. Again, thank you for your participation. We'll see you at the next event from ASCO Power Technologies. Goodbye.